The climate change happening worldwide is mainly caused by the excessive emissions of greenhouse gases, and it is threatening our future. One of the main sources of these emissions is the electricity generation that can be sourced from highly polluting fossil fuels, such as coal or natural gas, or clean renewables, such as solar, wind, and hydro, with a carbon content that can be up to 250 times lower. Unfortunately, most of the power created in Alberta comes from coal and natural gas, but there is hope. The world is fighting to reduce emissions from federal to individual levels. The Canadian government is committed to the Paris Agreement. Alberta has the 30 by 30 program to have 30% of its energy production sourced by renewables and eliminate coal-fired power plants by 2030. To become sustainable, the City of Edmonton is aiming to lower emissions by building energy retrofits, solar power, LED streetlights, replacement of diesel buses with electric ones, and the purchase of green electricity for city operation. My research is focused on the solar energy generation potential installed in city-owned sites. Alberta and Saskatchewan are the provinces that most received sunshine in Canada, and Edmonton is the fifth major Canadian city in terms of solar irradiation. This, and the fact that solar generation benefits from colder climates, makes Edmonton a very suitable city for solar energy production. And, believe it or not, covering a panel of snow does not affect its performance so much. A study from the Northern Alberta Institute of Technology showed that the annual production of solar energy for panels that remain covered in snow is only 5.3% less than the panels that had their snow regularly removed. I researched several configurations of solar panels to be installed in city-owned assets. Considering both the climate and the geography of Edmonton, my main focus was on solar panels installed directly on rooftops, mounted on the ground by fixation structures with poles, integrated on carports for parking lots, and even building integrated photovoltaics, a technology that allows for parts of the building, such as facades, curtain walls, shading systems, and skylights, to be made with solar cells. The main considerations were cost per energy production capacity installed, if structures that would receive these systems can handle them, and how each configuration would behave under the harsh winters. My main goal was to find the most affordable configurations, for the city to be able to install more solar generation with the same budget, allowing a greener grid to be achieved sooner and reducing more emissions. Besides affordability, the configuration chosen must be easily implemented, considering several city-owned sites and the sparse city geography. At the end, the rooftop-mounted configuration proved to be the most suitable for installation in city-owned assets. That's how the city of Edmonton will bring the sun to the snow.